Hi everyone, welcome back. We are going to review a couple of things about functions and then we're going to go to exponential functions. So this is for you to see this information first so that you are ready to tackle it in high school. Okay, so a linear function, remember that it is a relationship between a value of x and a value of y, and they make a coordinate pair. So if we create our table here and we create some values, x and y, and we choose our x values. So let's say for a linear function, we're gonna choose the values 0, 1, and 2. And the function is going to be miles per hour. So we need to find out the speed, the rate, the slope. So y is equal to 60 miles every time we have an hour, 60 times x. So when x is 0, time hasn't started. So 60 times 0 is 0 miles. So this is hours and this is miles. Okay, what about when x is 1? It would be 60 times 1 to find y. So the value of y for x is when x is 1, y is 60. And when x is 2, 60 times 2, that's 120. Obviously, if we are going to 120 miles in 2 hours, it is the same as saying 60 miles in 1 hour, 120 in 2, 180 in 3, and this is a pretty basic function. And to graph it, we can design my y-axis to have the required values of 60, 120, and 180, like that. Of course, the values for x were 0, 1, 2, and 3. So we plot the points, 0, 0, right here. Then we're gonna plot the points 160, 2 on 120, 3 on 180, and we have a basic linear function. Okay, let me see, hold on, if I can erase that. You can pause that and you can copy this, the first graph for your notes, linear function. Okay, so let me see if I can erase now after you pause and do your pairs. All right, so now we're going to do quadratic. Quadratic means that it's going to be a nonlinear function, and quadratic means square. So to find y, the y value for x, we need to square whatever x is. So again, we create our little table, and this is a review of what we did last week. So x and y. We're going to choose different values for x, -3, -2, -1, 0, 1, 2, and 3, hopefully. And I just need to extend my table. This is not a contest about who draws the best table, but just to have it. Although I appreciate you guys doing really good with these things, using rulers and colors, I love it. Okay, so how do we find the relation or the value of y when we have an x value? And remember, we chose this at random because they're close to the origin, so we can graph whatever we need to graph. Okay, so y is equal x to the second power. Let me think. So that means y is equal to x times x. That's what x to the second power means, if you remember. Y is equal to x times x. So let's start with with x is -3. So when x is -3, y is going to be equal to -3, sign included, times -3. Let's see, we're multiplying, so negative times a negative is a positive, and 3 times 3 is 9. So when x is -3 and we square -3, like this, -3 squared, we get that y is equal for +9 whenever x is -3. So how do we find the value of y for x -2? We square -2. -2 times -2 is +4, right? For -1, -1 to the second power is -1 times -1, which is a +1. 0 yields 0, and 1 gives you 1, 2 gives you 4, and 3 gives us 9. Okay, so that's the table. I want you to pause the video and copy the table so that then we're ready to do the little graphing quickly. Okay, so, all right, so now we need the x value. Notice all my y values are positive, so all I need is quadrants 1 and 2. And we chose at random -3, -2, -1, +1 for x, 2 for x, and 3 for 9. And we use the table to find our coordinate pairs. The first pair being -3, 9. So we're gonna have to go all the way up to 9 here. Not to scale, obviously, but let's see, that's 9, that's 1, 2, 3, 4, 5, and so on. So we have a point right here at -3, 9. Where's my microphone? Okay, at -3, 9. Then -2, 4, -1, 1. And because I didn't draw it to scale, it almost looks like a straight line, but it's not supposed to be. So, so it's supposed to be more like a curve like this that is going to go the other way too. So this point probably belongs more like right here. You can fix it, and that's that. So you can now do a much better job than what I do, and you can graph this again for your notes. So you need 3 graphs for your notes. Linear, quadratic, this is y equals x to the second power. Now we need to pay attention to the next one because it's brand new. And again, I'm not going to give you a test or quiz on this one. I simply need for you to look at it for the first time and see what this is. The exponential function is called that way because we're going to be using exponents, but what's going to be the exponent? My x value. So we're going to do the basic y equals 2 to the x power. So when we create our table, again, we choose random our x values. May I suggest that we start with -1, and then 0, and then 1, 2, and 3. That's all we're going to need for the x values. Now, how do we find the y value? We need to use, obviously, the exponential formula. So y is always going to be equal to 2 base to the exponent that x is. So in the first case, I'm looking, this is a plain, the Zoom whiteboard that doesn't let me see if I can change the color, but I don't think so. Anyway, maybe next time. So anyway, so you see the x right here. on the equation. So I'm going to use y for the first point. Y is equal to 2 to the negative 1. And we don't need to go into review of the negative exponents, but basically we turn it into a fraction and then we flip the fraction, and now that becomes 2 to the 1, which is indeed 1 over 2. I don't want you to be concerned about flipping this. Just trust me that when x is negative 1, y is equal to a half. Okay, now 0. Y is equal to 2 to the x, and x is 0. So what is y is equal to 2 to the 0? Some of you, including myself, are thinking 0. But no, remember, exponents is multiplying and dividing, so we don't use 0. 3 divided by 3 is not 0, it's 1. So 2 to the 0, or any base raised to the 0 power, gives you 1. Maybe now you remember. So when x is 0, y is 1. What's happening when x is 1? Y will be 2 to the 1, and 2 to the 1 is just 2. So when x is 1, y is 2. And what we begin to see here is that things are going to double. So when x is 2, y is equal to 2. We always have that 2 base, and the exponent is what's changing. 2 to the 2 again is 4. And now when x is 3, again, we're gonna do y is equal to 2, because that's what it's in the formula, the 2 never changes, to the x power, and my x power is now 3. So 2 to the third power, that's 2 times 2 times 2, so it is 8. So when x is 3, y is 8. Okay, so now copy the table, pause, and then we're gonna graph this. So we see that things are doubling from 2, from 1 double to, from a half doubles to 2. 1 times 2 is 2, 2 times 2 is 4. So things are doubling. That's why this function goes high, goes up very quickly. So copy it, and then we're gonna finally graph it, see what the basic shape is. All right, so we are going to have to use here. I chose -1. But then we need to go up to 8. And I think it's important to make that happen so that 8, let me see. If I divide that, and that is 4, I would need 5, 6, and 7. And here I would need 1, 2, and 3. So this is my half for y. So 8, 7, 6. You get the idea. A half is between 0 and 1. So this is a half. 1/2. All right, so my point is -1. Then we had 0. Then we had 1, 2, and 3. So plotting, our first point was -1, gave us a half. 0, remember, is 1 because anything to the 0 is 1. 2 to the 1 is the same as 2. There's 1, 2. There's one number 2. So then when the exponent of 2 is 2, that means 2 squared, 2, 4. And when the exponent for the base 2 is 3, that means 2 to the third power, or 2 cubed. So it's 2, 8. And so we're gonna start with -1, and a half, 0, 1, 1, 2, 2, 4, and look what's happening now. When we go to 3, it goes to 8. And you can imagine if we only add one more here, it needs to go all the way up to 16. So off the charts. So this is an exponential function. And the basic shape is going to be a curve that is going to rise very quickly. As we go to the left, it's gonna get closer to the x value, but it will never be a negative number. So this is what happens with bacterial growth, with diseases that get spread at a certain rate. This one here, remember, that could be a week, and so on. We need to, whatever the parameters are, we just see that this can go up very quickly. So why is this a problem? Because if too many people get sick at the same time, we don't have enough resources to help them. It's all. However, I have good news to end this lesson. Pause it, copy your points on your graph. This is the graph of y equals 2 to the x, and it's an exponential function. Okay. And I said I'm gonna end with some good news. As you know, this is what's generally happened in the countries with the virus. You can pause and copy. But the good news is that if we looked at the chart for Miami-Dade County, and I looked at it, it doesn't show like an exponential function. It's something like this. So that means that we don't have that risk of having too many people sick and not having enough help, enough hospital beds and whatnot. So this was, obviously I don't know the name of this function. It's not linear, but it's certainly not spiking. So it looks like social distancing is working in Miami-Dade. However, that doesn't mean we're good to go, because Miami-Dade is the county in the state with the highest number of infections. So we need to continue to keep social or physical distancing, washing our hands, and being safe. Thank you so very much. I'm going to stop this recording. Okay, I will post this in Edmodo.